So thank you all for coming. Welcome to the first Tech Forum of 2018. I'm your host, Tom Clark, and for the next hour we'll be learning about a technical subject that interests us all. It's going to be about Elm, and it's going to be our good friend Dave Smith presenting it. So please give it up for Mr. Dave Smith.
Thank you. I would like to start by saying I'm not alone today. Lee Smith here is going to... Well, the talk is in two parts. My intention is to waffle on for a bit and try and get you interested in what we're talking about, and then Lee's going to do the bit you're actually here for, which is the programming. Hang on, I'm going to try my clicker. Fail.
AV Sports.
No, it's fine. I'm just going to press buttons. I'm fine. Oh, yeah. Thank you, Tom. So Elm. Elm lets you build stuff like this. This is Oliver, named after our very own Oliver Fisher upstairs, because he's been begging for this for such a long time. It's maintained by the Scala devs and online. It was actually built by our RTS placement student, Bede, originally. I did a smashing job. It's in progress, but it's an image search UI. Right, we don't do kind of public facing interfaces, but we have tools that we need to present to the company so they can do stuff for us. Since we started using Elm, I've been shouting about it for a very long time now, and since we started using ITV, I thought I should try and explain it to more people within the business, not just random folks in the streets saying we should use Elm. That's a very large picture on this television, but this is Evan Cipliki. I'm not going to try and pronounce his name again. You've heard it. If you missed it there, you've lost it. Evan's is a very lovely chap. He does lovely talks. He's got a very nice presentation style. And Evan here is on a mission to make web dev a nicer experience for everybody. He's sort of propagating niceness. I think it was back when he was doing his doctorate. He was looking for an original idea, as all good doctoral students do, and he thought he'd stumbled across something great, which was immutable front-end web development based on streams. He thought this would be brand new and shiny. And then, like all doctoral students, he realized that actually somebody else had thought of it before he did. Back in 1996, Microsoft released a system called Fran, which is functional reactive animation. Evan kind of built on that and integrated it with a system called functional reactive programming, and he ended up with Elm, which he proposed in a paper in 2012 called Concurrent FRP. If you want, like I say, he does lots of lovely talks. If you want to find out more, I'm going to be stealing liberally from some of them later. So, very quick context of what Elm is. I don't want to hover on this for too long. I've got other things to talk about. Elm is a purely functional language, which basically means it's free of side effects. If anybody was wondering what a side effect, what constitutes a side effect, print line is a side effect. We don't do that. It's immutable, so you can have a lot of confidence in what you're doing, lack of race conditions. Statically typed, lots of compiler support. More on that later. Designed specifically for web development, Elm is a specialist language. And again, I'm going to come back to that in a sec. The last line is really important. If you're assessing whether you should use a framework or a language or a tool to do front-end dev, Elm stands apart from the others in one important way, which is you can basically find a 2JS compiler for any language you like these days. You can use Idris if you want, if you're feeling brave. But you will need a framework. You'll need React, you'll need some sort of FFI bindings to those frameworks so you can still talk to JS. Elm is different in that it abstracts over HTML, JavaScript, and CSS together. Right, so it all kind of gets done in one big lump, right? So you don't have to think about these things. Right. Fun facts. Cross-browser. So I'm an ex-Flash person. Don't think less of me. I really enjoyed it. And one of the things I liked was that you compiled it once and it worked anywhere. Elm pretty much does that too for browser, all modern browsers. No runtime errors, which is something that JavaScript people should be pleased about. There's no such thing as undefined. There's no nans. There's no nothing. If it compiles, you will not have a runtime error. Almost. If you work really hard, you can make one. But you have to want to. It's good fun. It's a good laugh. All the people who use it in our team really enjoyed it. We can talk, if anybody's interested, we can talk about how we assessed it later versus Scala.js, but we can come back to that. Performance. Now, admittedly, this is taken from Elm's website, right? But this one's Elm. Smaller is better, right? They used to have, this is from a post called Blazing Fast HTML Round 2. In the original one, there is actually another framework which is even quicker. But it's based on Elm, but written in normal JavaScript. Okay, so this is Ember, React, Angular, Angular 2, and Elm. And that's the optimized ones at that end. So it does very well. Elm's impact on programming. This one, it's really underestimated. It's really understated how much Elm's influenced the rest of the world of programming. Elm turned up in this book, I think it was 2014. Strapline, Languages That Are Shaping the Future. Many of you may have seen the original book, which is 7 Programming Languages in 7 Weeks. This is John Carmack, who you probably haven't heard the name of, but he made a small game you may have heard of. He now works at Oculus for Facebook, still doing graphics. And he said, this should be an inspiration for every error message. And it's Elm. I'll try and read that out quickly. So this is taken from an error message generated during compile time. Okay, this type alias is recursive, following infinite type. Here's the code sample. When I expanded the recursive type alias, it just keeps getting bigger and bigger. So the aliasing results in an infinitely large type. Try this instead. Let's rework that into a nicer thing. This is a kind of simple subtle distinction. Sorry, suggested a naive fix, but you could try doing something else. And now, of course, Rust does this. And Scala is heading this way too. So this is the future of your compile error messages. More widely, the architecture of Elm has massively influenced the industry. Back when I was first looking at it, it was pretty much the only thing using virtual DOM and that kind of loop. Redux lists it as a direct influence, which is obviously paired with React. If you look around, lots of the other modern frameworks and stuff, you can see the influence. It's all there, the same sort of syntax, same sort of structures, same sort of flow. More on that in a bit. And time-traveling debuggers are coming into fashion. If you've got a language that doesn't generate errors, right, what on earth do you need a debugger for? What runtime code are you stepping through to find a null exception when there isn't any, right? So a time-traveling debugger is actually it's actually used for debugging behavior, right? So if you've got a menu which is sliding out and you think it's a little bit too quick, you can roll back in time, tweak some values, and play it forward again and see what happens, right? It's not about debugging the way we usually think about it. Right, so the talk is called A Language Designed on Purpose. What on earth do I mean by that? All languages are surely designed on purpose. They're all designed to fit a niche. But general purpose languages, the niche they fill is actually about expressing solutions. You know, how am I going to express the solution to a particular problem? Specialist languages don't work like that. There's another specialist languages you may all be familiar with. It's called SQL. That's a specialist language. In that its constructs are only used for one particular job. You can't use them anywhere else. You can't write a command line application in SQL. You can't build a web page in SQL. You might be able to destroy one if you know what you're doing. But interestingly, Elm is even more specialist for me. It's a very, very considered language because it's not just designed for a specific purpose. It's designed for a very specific community. Okay, so we're going to have a quick look at 2 core concepts, who it's for and how it works. Hopefully, I'm going to start with who it's for. Hopefully the how it works will segue beautifully into Lee's demonstration later, because he should have some idea of what's going on before he starts showing you stuff. This next part of the talk is very heavily pinched from part of this talk, which is very good. It's called Let's Be Mainstream, where Evan is talking about how you build a community around a language. And I couldn't think of a way of saying it better than he had, so I'm just going to try and show you that, and hopefully he won't hate me for it if he ever sees this. So again, his mission was to make web dev fun again, but fun for whom? Okay, here is a graph. We're going to plot programming languages on it, based on whether they're intuitive or maintainable. Okay? There's our first candidate, JavaScript. Okay, so with JavaScript, it's super intuitive, right? You can, even if you're not really a programmer, you can get started pretty quickly. The barrier to entry is tiny. You need Notepad, you need a browser, you need a lot of patience and possibly a nice tutorial. But you can get going and you can build something nice in like an hour, okay? A language which is typically thought of as being maintainable, right? I picked at random. I must say, I very intentionally left Scala off here because that's an entirely separate talk, right? Java is OO. There's lots of design patterns. There's lots of ways to structure it so that it's fairly maintainable. Lots of people built amazing, impressive things with it. But the barrier to entry is higher, right? You have to learn about these concepts of classes and hierarchies and JVMs and jars and class files and bytecode and all that kind of stuff. You can't just kind of get stuck in and hope that it works. What's interesting, though, is most people don't realize this graph is at the wrong scale entirely, right? What sort of beast lives up there if you rescale the graph so that Java moves, right? Well, it's Haskell. It's basically all of the big hardcore functional programming languages, OCaml, ML. They probably won't thank me for saying this, but that's kind of the truth. These languages are, when you write the programs in them, they're vastly maintainable. They're really elegant, lean things, right? That are easy to test, and you can reason about how they're going to work very, very well. But the barrier to entry is really high, right? You have to learn a lot of stuff just to get started. You have to know what a functor is, right? You kind of can't escape it. And so the question is, if you want to do web dev and you want it to be nice and you want it to be intuitive and maintainable, and you're trying to build a language that people are actually going to adopt, well, who do you pick, right? Because clearly these people have different requirements and different desires, okay? And the best way to do that is to look at relative dev population size, right? So there are, a few 100,000 Haskell programmers in the world, or there are billions of lovely JavaScript people bashing away at keyboards building websites. You can either try and move these people over here, and they probably don't want to go anyway, let's face it, or you can try and help this community here and try and give them a better life. And that's really kind of what Elm is focused on. Its entire pitch is at this corner of the market, okay? Which, that was a slight joke, but this is kind of what Elm is all about. They don't talk, they avoid language like monads, right? JS developers have never needed monads or functors or co-free applicatives, and they don't care what they are, right? It's not that they can't learn them, they're just not interested, right? I've never needed one before, why would I need one now? You want to give me a better life, but you want me to go and learn about monads first? No, it's okay. So what we want is to give them all the benefits of these wonderful structures, and they are there in Elm, but don't give them any of the stuff that's off-putting to make sure they lure them in, And as such, sort of hard design choices have been made in the language in order to keep it welcoming to the intended audience, and it does draw some criticism from the other end of the spectrum for that reason, because they're saying, well, it should be a functor, surely, because it is a functor. But never mind. Okay, so that's kind of who it's for. I'm going to charge over. I have no idea where I am here. Right, okay, good. Oh dear, sorry. Oh my goodness. Leave me alone.
Fade away when you
there we go. Right, good, thanks. Yes. I'm gonna cover some high-level concepts of the architecture behind Elm. We've got quite a wide audience here, so I'm not going to dive into any of it in any great depth. I just want to try and touch on what the difference is between scaling a normal front-end application versus an Elm application. So the usual suspects for front-end development, if you've ever done any of it, are these guys. Actors rock up occasionally. ECS is the entity component system. It's a very big thing in the games industry, although not many people, quite a lot of the engines that are out there don't officially subscribe to it, but they're all doing the same thing. It's basically a point in space with a label, and you attach components to it to create objects. and then, of course, there's the daddy of all the patterns, which is the MVC pattern, and its various derivatives, MVVMC, MVVM, MVP. There's a pattern for everything. And we're going to look at that one. So, model view controller. I thought of an example earlier. What was it? Yeah, somebody updating their date of birth, right? So somebody's looking at a form. They enter a new date of birth. For some reason, they were born on a different day, or it was incorrectly entered the first time round. That triggers a view event to a controller. Controller decides what to do. Might be a database change first, something like that. That may result in an update trigger to the model. The model is changed to reflect that, and the view redisplays the difference. Okay, it's a very simple pattern. Goes round and round and round, and combined together, they make what are quite often referred to as components. And when you're scaling out a program with these components, there's kind of two strategies. One is you can just have enormous models and views and controllers, right? But it's going to get into a mess really quickly, right? So mostly people do this. They nest components. They say, okay, I'm going to take this whole block, and each one of these is going to be them. So maybe this is the top of your design application, and then all the way down here we have a color picker. And that's fine. He's got his own little MVC that he's going round and round. He knows what colors are available. He knows what's in the custom palette. But this guy is controlling the windows, which is all fine. But eventually, the color picker has to tell the paintbrush that they've changed to red, right? And that's where it all starts to go wrong, because this happens. And it's all there. It can be managed with good design patterns and rigor. You could do it in imperative code if you really wanted to, but it's quite hard to follow the flow of events as they fall around. You can end up with race conditions and stuff like that. So, Elm works differently. Elm is originally designed based on the thing, as I said before, called the FRP pattern, which is functional reactive programming, which is really based on the merging of streams. We see it in Scala server-side programming a lot, which is all about taking streams of data and merging them together and processing them based on that. Although it's referred to as signals. More recently, Evan has said he wasn't aware of a thing called synchronous programming when he made this in the first place. But synchronous programming is also a good analogy for Elm, as long as it takes concurrency very, very seriously. And basically, what happens is this. Elm is a runtime. It's JavaScript. And the only thing that it ever does is emit messages, a stream of messages, a signal of messages, however you want to think about it, such as a keyboard click, a mouse move, a new render frame has been updated, something like that. It goes into some sort of update process, and then it spits out HTML at the other side. It just goes round and round and round and round and round. That's all it does, which is actually pretty much what the browser does as well. Breaking down updates, you have it basically falls into three parts. I'm going to come back to update itself in a second, and you'll see some of this when Lee shows you in a minute, hopefully. You have a model. The model, there's an initial model, which is, if you were doing an address book, it's probably going to be an empty list of contacts initially. You then have this update process, which I'm going to come back to, and then eventually you have a view, which is, should look fairly similar to the MVC pattern, where you take a model, and by some mysterious process, you translate that into a rendered HTML output. So, just if you're not familiar with the function signature style, this is just a function. This is a bit JavaScript-y. Essentially, take a message and the old version of the model, combine them mysteriously with a plus, who knows, into a new model and return the new model. That's all that does. So the model, that means that the model's immutable, right? This old version of the model is always the same. It never gets updated. No values in there are being touched, which means it can be stored as each cycle of the application can be stored as a stream of diffs, which is how the time traveling debugger works. You can just play them backwards, or you can undo it and play it forward again. But what's interesting is, no matter how big the program gets, this is always the entry point, and that function signature never changes, unless you're doing a more complicated program, but this is like the basic one, okay? So how does one scale such a thing? Well, basically, components become functions. So these guys are now functions, not objects. Here we go. So here's my message in my original model. By some function, I need to produce a new model, which is the next version of my state, which will be rendered. Okay. I could go on and on about this, but I'm not going to today. What we do to make that bigger, if we decide that there's, the simplest thing we could do here is we could just return the old model again. If the model actually never changed, I don't know what use this is ever going to be. Maybe it's a static web page. There's no updates to be done. It's just rendering a view, right? Then you could just return it immediately. But maybe you want to go and look up a data set in a database or a HTTP. Maybe you want to use that new data set to calculate a new position of something. And eventually you want to take that and turn it back into a model. And each one of those has a pure referentially transparent function which is completely testable because it's isolated. It's not nested in the other components. And then all that you do is you compose them together. So f is no longer a real thing. It's abstract. F is the composition of g, h, and I, which, if you were calling it, is like that. So it's g called with the arguments, which is then supplied to h, which is supplied to I. Right. The thing to note here, though, really is, we're back to this idea that it's a specialist language, right? You can't do anything else with it, right? These functions that we described earlier, these are baked into the language and ecosystem, right? They're all part of the environment. So, oops, Daisy. Mm-hmm. There's nothing else you can do, right? It's a bit like SQL. You can't. SQL has select baked into it. That's all that it does. It's there for doing database access. It doesn't do print lines to terminal or anything like that. So designed for a very specific audience, designed to do a very specific job, and that's me about done. So I'm going to hand over to Lee, hopefully, who's going to show you what it looks like when it's running. So I just unplug all the things. Okay.
Do you want a clicker? No, it's right next to you. There we go. Takes time. So this is where it all horribly goes wrong. So this is the start of an Elm application. We started here because I can never remember what the imports are, so cheating a little bit. So you have this beginner program, so it's like a little helper function that helps you spin up a little app easily. And that takes some parameters, but I can't remember what those are. So let's see if this Elm errors helps tell me. And yes, it does. So it needs a model, an update, and a view. So those are the functions that Dave was talking about earlier. So let's see if we can supply those. So a model, for this we're just going to make a really, really simple model, which is just going to be a number, an int. And we also need an update function, which we will call update, and a view, which we'll call view. So we'll have to define those two functions. So update, which will take a message model, I believe, and then that will return the model again. So based on the message, it will know what to do and how to modify the model. So we also need to define what the messages are going to be. So if we create some types, if I remember the syntax of this, so if we have an increment message or a decrement message, so then that will be the message that the update function will take and apply that to the model. So if we then pattern match on this message, so if it's an increment, we want to increase the model by 1, and who can guess what you do? Take 1 off. So that's the update function. So then we also need the view function. So this is where you describe what the actual page looks like. So all of the HTML, CSS, and all that sort of stuff. And that just takes a model. So we'll just have a div, and the first set of brackets is for the attributes. So just like any sort of normal HTML, you have the attributes that you would apply. and then you have the content within that div is the second. So let's see if that compiles and what that looks like. It does, and it's just an empty page. So let's try and add some stuff to that. So first we want a button. So again, everything has these two square brackets, attributes and content. So if we add a couple of buttons. So first we want the button, if we give this button a label. So we can associate that with the two events. And we want it to make it actually do something. So if we say on click increment, on click, and we want to actually display the number as well so we can see it changing. So that'd just be some text, but let's put that in another div. Text model, and let's see what that looks like. Yay, more errors. So it looks like problem is in the view field. Cool. These helpful errors are so it's saying that it's a string, but it should be a number. So I think this one should be a string instead of a number. Is that the one? I think that's got rid of one of them. And it's saying that this one also, that's a string, but it should be HTML. So we want that to also be a text element. Cool. Now we have a page. Is this going to do anything? Yes. And just briefly, this is like the time traveling debugger that they've mentioned. So this is all of the events that were sent. So it records those so that you can replay those and you can see the state changing based on the message. And that's about it. Would you like to wrap up?
No, I mean, really, the goal here was really just to say, hopefully inspire you to have a go at it. Elm's one of those languages that it's kind of got a limited community. It's had a massive impact on the industry, as I've said. One of the things that I mean, I don't use this every day, I'm a Scala dev, but it's changed the way that I look at my programs vastly just by learning and having a go, so I would encourage you to do the same, whether or not you adopt it on your teams. That's about it. Thanks very much.
Okay. Other questions?
Hello, Alex.
CSS.
Yes.
Do you actually just write the CSS and then include?
There's so Elm has a very good package manager which does not allow bad packages to be published and stuff like that. And one of them is Elm CSS. There's a very good talk by a chap called Richard Feldman, who's one of the big people in the community, where he wrote Elm CSS. It's called Making Impossible States Impossible, where he's showing how he designed the API for Elm CSS so that it was impossible for you to produce a badly formed CSS output. And it basically, so what you end up with is compile time checked CSS correctness. Does that answer your question? Anybody else?
So we saw that we saw an example of event binding where, like, on click we triggered an increment or decrement.
Yes.
And the event was something which you defined within, like, your specific, like, ADT, which was like this, the union of these two types.
That's right.
What happens when you have other, like, browser-specific events like keystroke or mouse move? Like,
So originally, so I started using Elm back when it was version 15, and now it's 17 or 18, and they've changed the terminology since then. But originally, Elm talked about a thing called signals, and I suspect it's still that under the covers. And basically, a signal is like it's always on. It's like an oscilloscope. So even when there's nothing going on, there's actually always something there, so you can measure it. And mouse move is quite an interesting one, because the mouse isn't doing anything. Signal's flat. Move the mouse, and the signal pulses, and you get a new message, right? And what you do is you choose to actively subscribe to those kind of messages and say, I'm interested in mouse movements, or I'm interested in updates from JavaScript, or clicks, or key press, any of that kind of stuff, or render frames, and then that then gets pumped into your update loop, so you can respond to it as appropriate. That's your question?
yep.
Anybody else? Hello, Tom.
So we talked about the MVC kind of like linking to your bits. I guess
Yes.
Obviously it's still taking that under the hood, but it's totally abstracted from you as the user. You just don't care.
It's
Because obviously
no.
you've got your browser state
Yes.
going through JavaScript with some kind of Ajax or whatever kind of
Yep.
seamless calls back in application. There's
Yep.
a lot of like magic going on there, but because it's
Yep.
under the hood, you kind of just
No, that's right. So Elm originally, as I say, Elm was written based on a paper called Concurrent FRP, and the idea was to take concurrency very, very seriously, and I/O and network calls and stuff is all part of that. But it was all about, again, at the time, it was all about this idea of signals, right? And for those of you who know what an applicative is, then, yeah, he knows, good. Right, it was applicatives, not monads, right, which means you couldn't have a signal and flatten them, but you could take two signals and merge them together, right? So if you had a state update where an HTTP call finished under the hood, it would bring in a signal saying this is the response that you wanted, and it just turns up in your flow of events, and you continuously process the stream of events, and each one just happens one after another, which means that you can never have race conditions or unexpected state changes, or you can't have two things modify the same value at the same time, because it just doesn't work. You have a perfect flow through, and it also reduces the sort of branching of your code base as well. But under the covers, you're protected from all that, but you don't kind of see it. And the hardest part for people learning is the thing that we always spend ages scratching our heads over is figuring out how you scale this thing, because you fully expect I'm going to make a new module which is a bit like my next MVC, and there'll be another update and viewing it, and those things do exist, but you call them from the original one. You just grow it out as a function essentially, so it's one enormous function. Mm-hmm.
Is the indentation, is it tabs or spaces?
Spaces, come on. You need to ask. Who else? Hello.
What were the things that made you choose Elm over Scala.js?
Good question, thank you. Originally, I said to the Scala teams upstairs, okay, we have this requirement that we have to occasionally build a UI. It doesn't have to be pretty because we're back-end devs, but we want it to be fun, right? So we do have some JavaScript in our system. It's in some lambdas, works very well. Nobody likes touching it because it's JavaScript. Nothing against JavaScript is, but it's just not a bag, you know. So I kind of said, right, we're going to have a day where we all try whichever frameworks you're excited about, right? And they'd obviously had me plugging Elm for quite a while. And there was another cohort that wanted to use Scala.js because we're Scala developers. PureScript was floated, TypeScript was floated. We didn't bother with any of them. Nobody wanted to. In the end, nobody actually wanted to have a go at them. Nothing wrong with them, I'm sure. Half the team did Elm, half the team did Scala.js. At the end of the day, we all scratched our heads and said, so which one's better? No idea, I didn't do the other one. So we did the same thing again the next day, but we swapped. And at the end of the second day, we still hadn't picked because we're indecisive. We had identified the pros and cons, which is with Scala.js you had to pick React or Angular. You therefore had to learn that framework as well. It didn't all come out of the box. It wasn't compile safe. It was only compile safe within Scala. If you're doing something that's very business logic heavy, then having a wonderful compiler to make sure you're doing it all correctly is really useful. But most of the stuff that we were doing is actually UI heavy, which means that mostly we're talking out to a JavaScript framework, and we're still prone to the same errors that the compiler can't protect us against, right? So in the end, the next time we had a project that came around, somebody said, I think it might have been Maya, she said, I'm doing it in Elm, and we'll see what happens, and we just haven't used anything else since. But that was our intended approach to assess it, was to let people try them and pick, and but in the end we just sort of plumped to one and haven't looked back yet. We did consider, I did wonder whether we'd end up using PureScript. When I first started learning Elm, I was not a functional programmer, and I was actually an OO person, and Elm was kind of fairly sensible to me because it wasn't too scary in terms of the terminology and the things that you had to learn to use it. Going back from functional programming back to Elm is slightly harder because there's things that you expect to be there, like type classes, right? And you just don't get that stuff. So you end up with more boilerplate, but overall it's simpler. And when we have juniors to bring on, that's an easier way in for them. A couple of unexpected benefits. Because it's Haskell-like syntax, it can be a bit of a gateway drug into Haskell. Also, it means that you can't write data structures the way that you do in Scala. So being able to say, hey, okay, this Scala structure looks a little bit messy. What would it be like if we had to do this in Elm? And doing a reflection is quite useful. And also, we've put it on the job spec, and several applicants have said they've applied just because we do Elm, which is nice. It's had some positive benefit to our recruitment process. Yes.
On this comparison between Scala and Elm,
Yep.
Are you aware of any Scala.js framework that embraces the Elm paradigm?
Yeah. So
there's
there's
FRP. Scala.js.
Well, I'm not completely certain, but there's one called Outwatch, which I looked over and it looks very similar. I mean, PureScript has another one called, I think it's called Pux, Pux. Which is also, I mean, if you look at them, they look the same to me. I haven't used them, so I can't say for sure. But you know, Elm's kind of helps inspire Redux, and that's inspired lots of other things to use a similar approach to UI development because it's just cleaner, it's easier to understand. So I think Outwatch also works for PureScript. It compiles to both Scala.js and PureScript. If anyone's interested, it's kind of worth looking at Elm just to learn the paradigm, and then if you apply that to something else, that's fine, you know. But it's interesting from a personal development perspective. Is that it? Okay, great. Thank you.
Thank you, Dave and Lee, for that really kind of fascinating talk, and it looks like quite a nice, pretty language. I want to even have a go myself. So I hope you enjoyed that. Next month we've got the UCL AI Lab coming in to talk about using AI for art investigation and restoration. Interesting topic. And if any of you would like to come and speak, please give me a shout as well. Or if you know anyone out in the industry, kind of peers or colleagues as well, you think if you could get in here, we'd be happy to host them. We'll give them donuts and maybe even an ITV mug or hoodie as well. So thank you very much. I think there's still some donuts to the left. Please help yourselves and see you next month.